Alright, we're going to start looking at now, continuing with our naming of ionic compounds, the positive and negative part, but we're going to add a piece to it, the polyatomic ions. So that's just going to be a small addition to what we've already been looking at with naming of our ionic compounds. Remember, the ionic have that positive and negative part to them. So to introduce our polyatomics, polyatomic, the word poly means many, atoms means our atomic means atoms, and ion is that plus or minus portion. So ion made of many atoms, but they act as one. And remember, they've got to have that many atoms as we're going, they have that charge to them. So either the positive or negative charge. Most of them are going to be negative, however. So NH4 with a plus charge, SO4, a group of atoms with a -2 charge, or OH with a minus charge. Those are just pictured over on the side here of what they actually look like. A group of atoms and the overall charge given on the outside. So overall they have either a positive or negative charge as a group. A specific group of those are called our polyatomic ions, are known as our oxyanions. Oxy for oxygen. So a negatively charged group of ions that carries a number due to the presence of our oxygen or varying numbers of oxygen. So an example of this, chlorine can combine with different amounts of oxygens. So as we're going, one example here, ClO4 with a minus charge is going to be known, and here's our root word, root, in this case with chlorine, perchlorate. Or ClO3 with a negative charge is going to be known as chlorate with that root and then the ate. Chlorite or hypochlorite are all going to be oxygen based. Now the good news is we don't need to know or memorize our polyatomic ions. Those polyatomic ions found in your gold packet on page 2. So all of these are listed out. You just saw the perchlorate, chlorate, chlorite, hypochlorite, and many others. It's broken down that anybody in this first column has a charge of -1. Anybody that's in column 2, charge of -2. And anybody in group or column 3, charge of -3. We have a couple only that are a positive charge. NH4 ammonium is going to be the most common positive one that we see. At the top of the page, we have some of our binary compound names for the nonmetallics. We've got our nitride, phosphide, and arsenide, oxide, cyanide, our sulfur, sulfide, cyanide, telluride, and then our halogens, fluoride, chloride, bromide, and iodide. But this is from your gold packet, page 2. You'll always have this as a resource. You just need to know how to use it. So everything is the same for ionic compound naming formulas. So again, we're going to start out by drawing a line. If we have a metal and a nonmetal, then it's an ionic compound. Remember the positive, negative portion. We're going to write the symbol and charge for each ion. Remember, we're going to use our gold packet and your periodic table. Roman numeral equals charge. That's again for our transition elements. The second thing, the anion, is on the second page of your gold packet. So a lot of times you can hear second thing, second page. The anion's the second one. It's on the second page of your gold packet. And then we crisscross and simplify those charges. Cations first, anion second. And this is the one that we need to make sure we include. If the number going to a polyatomic is 2 or greater, put it in parentheses, with the subscript number on the outside, that number going to it if it's 2 or greater. So here's our practice problem. Iron 2 nitrate. Draw a line between the two. If it's a metal plus and a nonmetal minus, then we're good to go. Iron to begin with is Fe with a +2 charge, given to us by that Roman numeral. Nitrate is not an element, it's a polyatomic ion. It's found on your polyatomic page. So if you were to look through, first column, partway down, NO3 is found there. NO3 has a -3 charge on your gold packet. So nitrate is 1 nitrogen, 3 oxygens with a -1 charge. We're going to crisscross, drop the charge, just the number moves over. Just the number, not the charge, moves over. So we have 1 iron, Fe, and we have 2 NO3s. To do this, we're going to put NO3 in parentheses, as our new rule states, and then the number, if it's 2 or greater, will be put on the outside of the parentheses. So we're taking 2 NO3s is what this is showing, not 1, or not writing it NO3 with a 2 next to it, so it looks like NO332. Nope. We need to write it out NO3 in parentheses with the 2 on the outside, showing that we have 2 NO3 groups. So to try a few of these out. Silver, Ag. Oh, drawing a line first. We have our plus, and then we have our polyatomic minus part. Silver always is going to be plus. Acetate, if we were to look back, let's see, did it make my list? Acetate's down at the very bottom. It got partially cut off. C2H3O2. But your gold packet will have that. So acetate, C2H3O2 with a minus overall charge. Silver always is a +1. So when we crisscross, we end up with Ag, silver, C2H3O2. No parentheses because a number is not greater than 2 that's going to the acetate. Zinc hydroxide. Zinc metal and then hydroxide from our gold packet. Hydroxide, if you look, is in -1 category. Partway down the page is hydroxide. Zinc hydroxide. Zinc from the periodic table is always a +2 charge. Hydroxide, always a -1. So when we crisscross zinc, 1, and 2 hydroxides, we will see this a lot. Please don't do this. ZnOH2. Note that these are different. We're only showing 1 oxygen and 2 hydrogens here. We're showing 2 OHs here. So please making sure parentheses around our polyatomic. Ammonium, first word, nitrate. Ammonium, remember, is our only positive from our gold packet. NH4 plus is one of 2 positive polyatomic ions. NH4, nitrate, we've seen before. NO3, whoops, with a positive. NO3 with a minus. If we have a +1, -1, when we crisscross, we don't write the 1s. We end up with ammonium, NH4, nitrate, NO3. And then our last one for writing out the formulas, copper 2 hydrogen carbonate. So drawing a line after the first element or symbol, copper is a +2. And hydrogen carbonate, if we were to find, does not quite appear on my chart. That's too bad. But we can find hydrogen carbonate as we're going. Is going to be HCO3 with a -1 charge. It was just further down on your gold packet than mine showed. When we crisscross, one goes over to the copper, hydrogen carbonate, is put in parentheses because the number going to it is 2 or greater. We put that parentheses on the outside to keep our hydrogen carbonate, saying that we have 2 of these complete sets. Remember, they behave as just a single atom, but we need to put them in parentheses in order for that to happen. Just the opposite, naming our compounds. So naming them, we're going to draw a line again, just as we've always, after the first element or NH4. If it's a plus and a minus, metal and a nonmetal, metal, nonmetal, we know it's an ionic compound. Determine the charge of the anion using our gold packet or periodic table. Charge of that must equal the cation. Remember, that's for Roman numerals and our transition elements. And then we name cation followed by anion. So sodium is not a transition element, so we just need sodium, which is a plus. And nitrate from our gold packet, nitrate, is a -1. Charges are already balanced. Name of that formula, NaNO3, sodium nitrate. So to try a couple practice problems out, NH4Cl. Now remember, if we see NH4, we draw the line after NH4. That's our only exception that we have, and then Cl minus. NH4 is ammonium, which has a +1. Chloride has a -1. So ammonium and chloride, showing it's the chlorine ion, ammonium chloride. Now B, probably our most difficult one that we'll have to deal with. Notice we have a transition element right away. So drawing our line, transition element of iron, we have to find out what charge iron has. So what we'll need to do, SO3 sulfite from your gold packet. So looking up for SO3 sulfite, I'll move back a couple. Sulfite, SO3 with a -2 charge. So finding that, and then using sulfite, -2 charge. Right now we have 3 of them. So 3 times -2 equals -6. So this side has to be a +6 to keep it neutral. So we have 2 of them, +6 divided by 2. Each iron must be a +3 in order for this to balance out. So when we name it, it's iron 3. SO3 here is sulfite. So iron 3 sulfite, Fe2SO3 taken 3 times would be our name for that compound. Alright. Na2CrO4. We have our sodium, the plus, and the chromate here. Chromate, CrO4 with a -2 charge, not dichromate, that's a little bit different there, is going to be the one that we look to. So chromate, so sodium, group 1 element, is always just going to be a +1, and chromate, CrO4, is going to be our negative. Now we could get this formula will always be sodium chromate out. Sodium chromate is always a -2, so it's a +1. So if we were to crisscross those, sodium would be 2, chromate would be 1. So we can move back and forth between the element, or the name, and the chemical formula. Copper sulfate, drawing a line between our first element and the rest of it. Notice right away we have a transition element, so transition elements, we need those Roman numerals. That's our hint right away. SO4, if you look to your gold packet, is sulfate. So right away, sulfate has a -2 charge. So if we wanted to, you could look back, sulfate, SO4, with a -2 charge on your gold packet, and we would use that -2 charge. If it has a -2 charge on this side, our side over here needs to be a +2. We have 1 copper listed, so it's got to be a +2 in order for us to balance out. So the +2 over here would balance the -2 over here, so in the end we would have copper 2 sulfate. Now notice, as we're going that gold packet, very useful, sulfate is different than sulfite, SO3 versus SO4. So it's important as we're going that we start looking at the names of those very carefully, because those root endings are going to be important as we're going forward. But again, polyatomic ions, groups of many atoms that behave as one atom. So remember parentheses if we need them.